Sir Isaac Newton was a famous scientist known for being hit on the head with an apple while studying motion and its concepts. After recovering from the hit, he realized something extremely important. He already knew that an object only accelerates when a force acts upon it. Therefore, if the apple was accelerating, a force was acting upon it. He called it gravity, and to this day we measure force in newtons.
The first law of motion states that every object remains in a state of rest or uniform motion in a straight line unless it is compelled to change that state by external forces acting on it. This is also known as the law of inertia. Inertia is the tendency for an object to stay at rest or continue in motion. Inertia can be seen in this demonstration as the bottle and skateboard are set into motion. When the skateboard is stopped, the bottle continues in uniform motion as it is not acted upon by an external force. Here, the objects remain at rest, even when the cloth is pulled from underneath them due to inertia. Objects at rest remain at rest. Yeah, that ball isn't going anywhere.
The second law states that the change of motion is proportional to the net external force and is made in the direction of that force. This law is often represented in the equation F equals ma. The greater the force we apply, the greater the acceleration is. Acceleration is in the same direction as the net force. If there are many forces acting on an object, it is the vector sum of those forces that produces any acceleration. In this next experiment, these two balls will have equal forces exerted on them. First, force is applied on the ping pong ball. The ball accelerates rapidly because of its low mass. When the same force is exerted on the more massive wooden ball, it accelerates more slowly. This happens because mass and acceleration are inversely related when the net force is the same. More than one force can act on an object. In this experiment, gravity and friction are the two acting forces. The crumpled paper falls much quicker than the flat paper, even though it has the same mass. The flat paper experiences more friction because it has greater surface area, which creates more air resistance.
Newton's third law states that to every action there is an equal and opposite reaction. As Adam exerts force and pushes Macario back, he is pushed back by the opposite force. The force exerted in throwing and catching a ball produces an opposite force which thrusts the thrower back.